Good morning, everyone. Hopefully you're not too hot. Speaking of heat, that's what we're going to be talking about today is how heat can be transferred. If you will, make sure that you are logged into the presentation. Um, Join at nearpod.com. There's the code. I'll give you a few minutes to get logged in. All right. Today, we're going to investigate a method of thermal energy that is known as convection. All right. So we know that heat can travel. We know that heat is energy. We've talked about that. We're going to now look at how heat can be transferred through substances that are fluid. Okay. At the end of today's lesson, these are the things that you're going to be able to do. I will demonstrate my understanding of convection by defining, giving examples, drawing a diagram, and completing my exit ticket. You will have three different things that you will produce to show me that you understand what convection is about. So you will have a definition page, you will have a diagram, and you will have your exit ticket. All right, let's get started. I want you to look at the diagram and I want you to notice just the details on the diagram. All right, great. Yes, there are arrows there. One arrow is red and the other arrow is blue. Now, when we're looking at a diagram for convection, we're going to be representing our warm flow or fluid with a red arrow and the cooler molecules or fluid with the blue arrow. All right, let's take a look at this diagram. All right, so as we know, substances are made of molecules, and those molecules can become dense or they can become less dense. We've talked about density before, and when we look at the convection diagram, sometimes you will see molecules in those diagrams representing the particles in the substance. So in this diagram, you see the convection current represented by the arrows that are blue, and the blue is sinking, and the red arrow shows the rising action. So when we talk about density, remember that the more dense something is, the heavier it feels. And so there's a correlation between density and heaviness, or density and lightness. All right, so let's take a closer look at those molecules. So when you add heat to molecules, the heat causes the molecules to really start moving. And so if they were tightly packed like the blue molecules and you were to add heat to it, the molecules are going to start they're going to start moving. They're going to start bouncing around. They're going to even, some of them maybe even escape the container that they're in. All right, so if this were the air outside, as the sun's warmth heats the ground, the molecules are going to start moving faster. They're going to rise because they are lighter now. That mass of air is lighter now, so it's going to rise up. As it rises away from the heat source, the molecules are going to cool down, or the air is going to cool down, and the molecules are going to become more dense, and they're going to become heavy enough to sink back down. So you have a cycle or a current that occurs because these will now heat back up, they will rise, these will cool down, they will sink. And so we have what's called a convection current. This is what it would look like if we could see it in motion. The radiator that is on the bottom right of your video is heating it up. So the heat source is the red arrows coming off that heat source. It's going to cool off, sink back down. All right, let me show you a different picture, and this would be more like in a fluid. All right, heat source is at the bottom. So your red is rising from the bottom, cooling off at the top and sinking back down. All right, any questions so far about how the molecules respond to heat and how that is what starts the convection process? All right, good. All right. Now, when we take a look at convection and air is kind of interesting because if you've ever wondered about where wind comes from, this is your answer. All right, so the air is going to be fluid. Remember, it moves and allows things to move through it. All right, so as the molecules in the air get warmer and start rising and then get cooler and start sinking, it's going to push the air. So it pushes the air and causes a breeze or causes wind. It's pretty interesting when we get to weather and we talk about wind. We're now going to have that background information that's going to explain the winds that we have occurring. All right, a different kind of example is how when you heat up, when the balloon operator heats up the balloon, the hot air rises and it picks that balloon up. If he wants to cool it down and stop the flame, then he can cause the balloon to sink back down to the ground. So by operating a convection current within the balloon, he can make the balloon, he can drive the balloon by using convection. All right, every day when you cook something on the stove, your heat source is at the bottom. So of course your convection current is going to rise from the bottom up to the top, cool off a little bit. Remember we talked about the molecules moving so much that some of them jump out of the pan? That's right. There's your steam right there coming right off the top of the pan. Some of those water molecules are going to be escaping. A different example in a larger context is your ocean currents. There's different types of ocean currents, and we'll get into that later in more detail. But as you can see, on this one, it's not color coded, but as you can see, the warmer water is going to rise toward the Arctic. The cooler water is going to sink back so that the equatorial heated water is going to push that big convection current in that motion. Also from top to bottom, the underneath in the depth in the deeper parts, you have colder water. Up at the top where the sun can move the heat through the water a little bit, heats that water, and you have that same current going on from top to bottom. All right. Now, this is going to make sense to you because I know that some of you have already looked into the plate tectonics and can remember a little bit about that from previous years. All right, so the plate tectonics, those big slabs of the Earth's crust, kind of float on that liquid-like mantle that has some fluidity to it. So you have some melted rock under there in the mantle, that magma that's fluid. Okay, so you have the same type of thing happening within the mantle of the Earth. You have a convection current because the core is extremely hot. So the core is heating up that magma, pushing it to the surface where it cools and sinks back down. And you have this going on in large portions under the Earth's crust. Now, I want to fast forward this just a little bit to get to the part where I want you to focus on. I want you to see this in an animated.
A way of helping to regulate the planet's temperature. It's a remarkable system. Magma heated by the core rises towards the Earth's surface. As it spreads sideways, the Earth's crust is very slowly dragged apart. This moves the continents, creating the Earth's restless and ever-changing surface.
Now, doesn't that make you excited to get to talk about the Earth and the plate tectonics? All right, so convection has a lot to do with many different things, including our weather systems and our extreme weather. So when we think about how can heat transfer, well, one way is through convection. Just think about all the things that are around us that happen because of convection. So when we have cold and warm air masses that meet, they can develop into tornadoes, into thunderstorms, into hurricanes, and all of those extreme weather um, conditions have the force behind them from convection. All right, so let's talk about what we learned today. All right, at this point, I would recap with the students and go through some of the main points and let them have a chance to respond back to some questioning. So we would spend a little bit of time in the lesson reviewing the main concept. After we review, there is a game that's built into the Nearpod that is pretty good. It is Time to Climb, where students would join in to the game format. And at that point, they would have some questions so they can kind of get a chance to see how they're doing. And I can definitely get a chance to see real quickly what they understand and what they didn't understand. At this point, too, I would go over with them their first component of their part. So this is what they need to do. They need to draw that detailed diagram. They can draw it with anything, any kind of example that they would like, making sure that they include the details. And I also provided them with an example so that they could see what my expectations are and what maybe a good diagram would encompass. If they have a vocabulary folder, something similar to this one is what I would be expecting them to put the definition in their own words, to give some examples, and then to illustrate simply with just some arrows that were color coded there. I would include with any type of reading or any type of information that I feel like they would need to reinforce their learning. There's their exit ticket connected right there where they would continue, fill that out. It would help me to see what they understood. Also include 2 different labs. These are simple labs that could be done at home. One lab shows convection through a convection snake that is done with simple things that most people have around the house, which also shows convection, but through a fluid. They can see what a convection current looks like on their own. Now, with the labs, I would definitely make sure that I started the lesson probably the next day, showing them those 2 labs, demonstrating them myself so that we could have that talk about, reviewing what yesterday's lesson was about, let them step me through the process of convection so that they understand, because convection is one of those concepts that through in science is going to come and reoccur all the time in different topics. All right, I chose Nearpod as my presentation mode because it allows for lots of different interactions. So the students can actually draw on the screens. I can draw on the screen if I didn't, if I had a different computer, I would have been able to annotate and make notes as I went through the presentation right on the screen. And they also can video read to them. So it has that audio button that will read the questions on the screen, or it will read the words that are on the screen to them. I would make sure that I was available for any student directly after the lesson, staying on with those that need reassurance or have additional questions, and then in small group later, making sure that I see what their diagram looks like and that they can show me their vocabulary so that I can kind of keep track of who's doing the work and what it looks like and whether they're understanding or not.